Now I'm going to demonstrate to you how we can use one sample t-test. So in this example, I have the height of 20 individuals measured in my classroom. I want to compare the mean height that I'm going to get from these 20 individuals with that of the reported by the national census. Say for example, the mean height for Malaysian is 1.67. So I'm going to compare the mean that I'm going to get here with the published record, which is 1.67. Okay, first of all, we have to examine whether the data are normally distributed or otherwise. So to do that, I'm going to demonstrate to you how to check for normality. Click Analyze, Descriptive Statistics, and then you go to Explore, right? And then you transfer your dependent list, which is the height, and then click Plots. I do not want to see stem and leaf. I just want to see the numbers. So I click Normality Plots with Test, and then Continue, and then OK. So now I can see that all the input that I want. So in case processing, all the entered data are processed by the SPSS. So that is good, no missing data. So I have skewness 0.271, kurtosis negative 4.82. So because I only use 20 subjects, so I have to believe the one which is prescribed by Shapiro and Wei. So if you look at the p-value here, it's 0.891. So that means the data are normally distributed. This is supported by the data for skewness and kurtosis, which are closer to 0. So now we are clear that the data are normally distributed. So we want to know now whether the height, okay, whether the height of the subjects that I measured, the mean was significantly higher or lower than that of prescribed census. Okay, now we go to Analyze, Compare Means, one sample t-test. Okay, you transfer the height, the test variable, option, okay, don't change anything. Then here you can see the test value. So this is where you can put in the data from census. Say for example, the height is 1.67 meter. Okay, now you click OK. So this is your one sample t-test result. You can see that the mean of height for your subjects is 1.6725 with standard deviation of 0.111. Okay, and then the test value is 1.67. Okay, so look at the significant value here, the two-tailed significant is 0.91, meaning that the value is higher than 0.05. So that means there is no significant difference between the height of the individuals that I measured in my classroom with that of published census. So that kind of conclusion that I can make.